Hi guys, good morning. In continuing the past few sessions, today we would be learning something called mean variance optimization. Right, so basically this is the definition. You use this tool or a framework basically to weigh the investment decisions. The investment decision as in what is your optimal portfolio. Sometimes this mean variance word is also called as efficient frontier. Though the terms are complex, they're like a little simple. What we are trying to do is either we choose high returns. Now, when we are choosing high returns, we have to choose a level of risk. What is the amount of risk you are taking? So we want to take the lowest risk possible and get a highest expected returns. So your 3 or 4 options would be high risk, high returns, low risk, low returns, or low risk and some medium returns. So you would be targeting that low risk and medium returns or whatever via some template. Right. So what we would do is we will also do an example. So if you recall, our data source is this BSC India. Right, so BSC India, market data, historical stock prices. We would select to do this analysis. We'll select 2 ETFs. One is your Nifty. So the Nifty, what is underlying? It is Nifty Bees. And we would do monthly. We would take last 10 years or 20 years, whatever is available. Right? And the usual stuff, if there is any split. Right? So here there's a split. So we will do this by 10. And this as it is. And we also will flip the data by month, new to old. So this is where my adjusted price, adjusted close or Nifty. So this data. And I will copy them here. Dates. I want my Nifty B values. So this is Nifty Bees. And I will get the gold data. for the same time. Let's see if there is any split. It is 2000, 2000, 2000, and then suddenly it dropped to 30. This is I think by 100, they have split 100 times. So this is my gold, and I have to flip this. So we have data only up to September 9 here, whereas this is October 9. Yeah. And this is my gold price. So I have to adjust it for values. I mean, copy by values, because there's a formula involved there. So this is your gold piece. Make both of them as 2-digit precision. Now go back to the slide. So the first portion is your returns, right? Returns is simply the weight of each asset. Each asset here is Nifty and gold bees. So if Nifty has given me like let's say 10% returns, and gold has given me 10% returns, and if I had put my 100 rupees as 50-50 into gold and Nifty, it is simply the average. So first I will calculate Nifty returns. This is simply this into this, and gold is same. So gold is up 2.5%, and Nifty is up 2.2%. So we'll reduce to 2-digit precision. Now we'll simply copy this formula across all the things. And we are looking at 10 years as a data points. So 10 years is how many months?
120 months.
So we'll only keep 120 data points and delete the rest. Right, so your Nifty returns and gold returns. This is simply average of Nifty. So on average, Nifty gives you 1.16% returns per month. And your gold is this, about 0.51%. Right. So now what I'll do is this is Nifty and this is gold. So if I had put 1 rupee in gold, then I don't have any money left. So it is 1 minus this one. So I am putting 0 in gold. Now I can do this in steps of any precision, like 1% reduction or 5% reduction or 10% reduction. Because 1% is too small, I will do in 5% steps. 5% is 0.05. So I'll put 95 in Nifty. Then how much I would be putting in gold? 100 minus 95, so 5 rupees, right? So that is what. You can do this all the way to 0. Right. So now the returns, right, is simply if I put 100 into Nifty, this one and this one. This one we have to lock plus this into this. Simply copy. Put 50 in Nifty and 50 in gold, your returns are 0.83% per month. If you put 100% in gold, 100% in Nifty, your returns are 1.16% per month. If you put 100% in gold, returns are 0.51%. And now it's a little better. We can read in one go. That is simply returns. Now we have to calculate risk. The risk is variance or standard deviation. Standard deviation is simply square root of variance. Now, how do we calculate variance? For a single instrument, it is easy. We can type variance.p or standard deviation and press input, it will come. Now, because we are taking two, it gets little complicated. This is the formula I would have picked up from internet. So you can see the links where is the source. Right, so the variance is simply W1 is weight of the portfolio, power 2 that is, and this notation O1 is standard deviation, right, into standard deviation of 1 power 2 plus the same thing for 2, that is the portfolio 2. Weight 1 is gold, weight 2 is Nifty or something like that. And then 2 into weight 1 into the standard deviation of 1 into weight 2 into standard deviation 2 into this Q is basically correlation between the two. So this is the formula. And standard deviation is square root of this. Right, so now we have to calculate standard deviation. So this is your returns. And this is standard. So standard deviation of Nifty is this one. And standard deviation of gold is more or less the same. I mean, Nifty is with a little 4.65% versus 4.07. The returns in gold are simply 0.5 versus Nifty at 1.16. Now, the variance of the portfolio is, we have to write that formula, right? So that is weight 1. This is the weight 1. Power 2 into standard deviation. So this is the standard deviation. And we shouldn't be moving. So I'll lock it. Function 4 and power 2 plus weight 2 power 2 into standard deviation of second item. So there is this and power 2. Plus this second stuff, right? Weight 1 and STD 1 and curve. So we don't have correlation. So we write what is the correlation. So correlation is simply curve of this and this. So that is about minus negative correlation. Strong, but if you just do R2, if you recall last class, so this is a square of this, right? So it's a very low R2. I mean, the Nifty versus gold, there's only 2% of the times they move in tandem. The rest of the 98%, they don't move together. There's no relationship. So last time when you have done that axis mid cap, your R2 was, I don't remember, maybe like 75 or 80, and then you said you are looking for a lower R2 number. So here you got a very low R2 number. So you should be making two assets because of the low R2 number, right? Now coming back to here, we have to complete the rest of the formula. That is 2 into weight 1 to weight 2 into standard deviation of 1 into standard deviation of 2 into the correlation. Right? This is the variance. Now this equation, I'll ask you a question, just try to attempt, right? Now your Sharpe ratio is basically for a risk-free rate set to 0, it is average divided by standard deviation. Now the standard deviation is square root of this. So any number, either a negative or positive, if you multiply it twice, it will become a positive number. So this is a positive number, right? Whatever you put, it will be some positive number. And again, you are doing the same with some other numbers. So again, it will be positive number. Now to reduce this Sharpe ratio, sorry, to get highest Sharpe ratio, there are two ways. One is either you can get highest returns and lowest standard deviation. Then the number is high. So this is a positive number, and this is also a positive number. So if you add two positive numbers, you get a bigger positive number. But you are looking at increasing the Sharpe ratio by reducing the standard deviation. Now, how will you make this number a smaller number? Right now it is at a a positive number plus positive number. So it has become bigger positive number. Now, how do you reduce that? So you have to subtract, right? If you subtract, the number will become small. So the way to subtract, because this is again positive. So the only way you can get a smaller number in this equation is by selecting a correlation which is negative, because if you multiply by a minus number, it will become minus. So these two positive numbers and you are minusing something, so it will become lesser number. So basically the lesson there is select two asset classes with negative correlation. That way you will reduce the standard deviation and increase the Sharpe ratio. Right, so now the standard deviation for this is square root of this. Now you simply copy it. Now you are calculating Sharpe ratio, which is simply the returns average divided by the risk. So we have calculated the ratio, right? We calculated the variance first. This is a bigger formula which we have simplified, or we have written the step-by-step instructions how to do it. And then standard deviation is nothing but a square root of that. And your Sharpe ratio is average divided by the returns divided by risk, which is standard deviation. Now your idea is to select the highest Sharpe ratio in this. That is the combination as per the theory. That is what efficient frontier or mean variance optimized portfolio. Where is that? Where is the highest Sharpe ratio?
.30.
Which one? This one?
Yes.
Because you can't read these numbers, right? They're all similar. So make it, I can't read 0.3 is the same. I'll just multiply it by 1000. Just some number so I can read it. So now this is the highest. Right, so that is your efficient frontier or mean variance optimized weightage. 60% Nifty and 40% to gold. Right, so now instead of doing a calculation like this, like all the steps, I do something called optimize it, or the analysis pack. I think Reena installed in some place, the data analysis pack or whatever, right? I think when she's explaining how to install that. So the same way you install this one, options, add-ins, Excel add-ins, go, and this solver. Okay. So you will get solver link. I'll just simply put 0.5 any combination, right? So, and copy this the whole equation, and my solver input would be change this and get highest of this. Solve what? Solve Sharp ratio M31. Yes, I want it to be maximum. How do I solve? By changing here. That's it. So solves, and it throws the same number. I mean, some new number, right? Earlier it was 0.5. We set now it is changed to, what does it change to? 59%. So that's your highest Sharp ratio portfolio. So 59% gold, sorry, 59% Nifty and 41% gold. You get a returns of average returns of 0.89, but your standard deviation is very low, 3. Right? So this is like a not low risk or high returns or whatever. So it's like a optimal combination where you are taking the least amount of risk of all that, and you are also trying to get the highest returns. The highest returns could be 1.16. It comes with a little higher standard deviation. Now, if you put only 100% gold, you get only lesser returns of 51.51, and your standard deviation is the same. Whereas in our optimized portfolio, you get 0.89 and standard deviation of 3. Now, what you also can do is you can do a graph. I think graph of standard deviation. We'll just call this as a risk, and the returns as reward. So risk is my standard deviation, reward is my returns. Now you can draw a graph. We get a graph like this, so you can adjust whatever. Now this is your risk. As you are going towards the right, you are taking higher risk. Now this is your reward or returns. As you go up, you get highest returns. And so as you go right, your risk increases. As you go up, your increases. Now there has to be a midpoint where you are taking lower risk and getting an optimal returns. So that point is this. Right? So that is your same equation. So this equation boils down to 0.59 of Nifty and 0.41 of gold. Now let me plug these values here, right? This is efficient front, that is efficient frontier allocation. What is that? It is Nifty of 0.59. So I'll just simply point to this, and gold of 1 minus that, or you can simply copy this. So my returns now would be gold Nifty into 0.59 plus this into 0.41. This G3 stuff I should be moving. Make it 2-digit precision. Right, so because I put 59 in Nifty and 41 in gold, I got 2.5%. I'll do this for all the years. And you also can do your 100 becomes analysis, right? You started with 100. This into 100 plus this. So in 10 years, your 100 has become how much?
275.
275, right? This is 100 becomes. Now what you do is you go back to this template. I think this is where she has calculated, right? Just copy all this. Copy to end. Call this as a Nifty and gold combination. The Nifty and gold combination is we don't want all this. We want only the percentages, right? Delete. Okay. So this will go. We'll simply get this. This is your Nifty and gold combination. We just copied the 100 stuff and we'll copy the dates. And this is T percentage is simply some reference problems. Okay, this is so we started on 10 years back, that is in March 12, and our 100 has become this one, and we have all the statistics. So we have 120 months. We win only 75 months, that is like 62.5 months, 62% of the months we win. This is average, we get 0.89% returns. And this you can go back and refer whatever the sigma means, this, that, and all. So average win loss. this won't be applicable here because we have to again recalculate them. And these are the other characteristics. So 100 becomes, you can read now. So your 100 becomes how much?
275.84.
And we are in the market for 10 years.
Yeah.
And our CAGR is how much? That is 10.7%.
10.7%.
Our maximum drawdown, we lost from peak to low at some point of time 15%, 14.47%.
47%.
And recovery time, so from the time of that to come back to our peak equity, we took 16 months. And we spent 68% of our, 68 months in drawdown, which is 56% of the time we spend in drawdown. That is the characteristics of this particular portfolio. And then you also can do a small trick here. So this is March, right? Just, I want only March. So this is your year-wise returns. So copy here. This is year, and this is what your 100 is. And how much is your profit or loss per percent in percent per year. This is simply into by this. Make it number, and you can color code. Greater than 0 is green, less than 0 is red. So we have 10 years. How many years we are profitable? How many years we are profitable? All the green.
8 years.
8 years.
And we lost in
2 years.
2 years.
and our maximum loss in a year is
2.67%.
yeah.
2020.
Yes.
This looks much better, right? You can bear only 2.5% loss.
Yeah.
Not a big deal. I mean, and you get about 10% returns average. That is the whole mean variance optimization is all about. So we have this is a graph which I took from the web. We also have the same graph. We can just paste it if you want. We'll paste it. Let's see. This is 59 gold, right? Sorry, 59 Nifty and 41 gold. So we have to go and where is that graph? This one. It's not open a paint. Here the risk has to be there, but I didn't put in the headlines or whatever the chart when I select. Right? So this is our efficient frontier, and the equity curve is equity curve is this one, right? Not up to here. Okay. Insert chart. This one. Okay. Things are put. Okay, I'll put here. And I will copy that. This is what our, I mean, I don't know why it's not so smooth, but that's okay. Our 100 has become like this. And year-wise returns. I mean, in case we want, this is what our year-wise returns, right? I think we have all the details, whatever we have done, right? So, any questions?
No questions.
Is it complicated or is it easy?
It's a little complicated.
But understandable.
Yeah.
All right, so that's the end of the session. If you have any questions, you can always either comment in the chat or you write the feedback in this email ID. Veena says not very difficult. Okay.